Our next talk is Sean Chittenden, Orchestrating Databases as a Service with Consul. Sean is currently an operations architect at Groupon, and it says here that he has been doing scalability or data center janitorial work for 15 years. So let's give a warm round of applause to Sean.
Thank you. Am I on? Can you hear me? OK, there you go. So orchestrating databases as a service with Consul. So this is not going to be the exact repeat of what was just said in the prior talk regarding learning from Consul. However, there are some interesting lessons learned that can be applied from just deploying technology writ large to deploying databases. We are in the process of rolling out Consul for additional orchestration. Inside of Groupon, there are some interesting things that we have done both for the introduction of Consul into our environment, as well as just general techniques for avoiding operational mishap. So a little quick background. So work at Groupon, large e-commerce site, we process revenue. We're in the business of selling things, right? If we go down for any particular reason, there is a direct and material impact to our ability to go and service the needs of our customers. So, but one of the things that has come as a result of this is, or in order to support this platform, we have gone down the SOA microservices road, right? We've made acquisitions. We have built things internally using very different types of technology stacks and ways of providing application interfaces to internal and external clients. And as a result, this means that we have a very large amount of complex things that are very small and elegant by themselves. However, when you look at them in a large context, it becomes kind of a complex environment, and complexity leads to failure because complex things have different ways of interacting. So one of the things, in speaking of databases, at the back of all of this is the database tier. And as we talk about service-oriented infrastructure, we have moved and canonicalized the concept of infrastructure is moving from pets to cattle, which is great, except for at the database tier. We really kind of don't want to, accidentally go and send a database off to slaughter, right? Like, that's a terrible, terrible thing. And that's fine if you've got, let's see if the pointer works here. That's fine if you have like little stateless apps, right? Like absolutely perfectly valid, right? Like go spin them up, go kill them, go do whatever you want. But when it comes to databases, right? Things that have inertia, like data has a certain amount of mass to it, and it doesn't instantly move from a single host, lightweight host, to some other lightweight host. Like the speed of light exists, data exists at rest. We fundamentally want data at rest, right? But in order to deal with this reality, we need to really treat databases closer to pets. But in this automated, infrastructure, do all the nice things universe, it's a little bit different, right? Like you don't want to accidentally, drive by and buzz cut your database. So, as a result, right, you've got the, let's say a bank of application servers talking to a series of databases, and this is great. And like this federated, infrastructure of many different applications talking to many different database timelines on the back end works, right? Like it works. It allows teams the flexibility and the ability to go forth, build applications, generate value for all of our businesses, right? And that's nice and all. And then things get a little bit more complex, though, because now you've got different workloads, right? Like if in this simple kind of workload here, you've got just an online application, that's great, right? You've got some kind of an SLA where this application talking to the internet expects that it's going to return a response in 10 milliseconds or something like that. Fantastic. And then some batch job is going to come through and just obliterate your database cache. So this is like slightly problematic because, now that batch job is now going to talk to your database. Right? When that does that and it blows out your cache here, you kind of care, right? You have this material operational impact. Okay, so this is on the system side of things. And what this results is you end up spending cycles running along looking at, random graphs like, hey, what happened here, right? Like, why did a handful of these hosts for these little tiny amounts of time, not large, but tiny amounts of time, did they spike? We don't know. Right? You generally want to be able to figure this stuff out, and it turns out that you go and dig through this stuff and you figure out that hey, there's some batch job that came through and just blew out the database. Okay, great. So that's a common problem, right? And then you find something else someplace else, and you look at the time, right? This is not an uncommon thing here. You got this event that happened for some chunk of your application servers up here because, not necessarily batch, but like something happened that caused this particular database to go sideways in terms of the latency response that you were expecting. So what now, right? So in the greater scheme of things, databases, you've got your typical web stack. Don't forget the browser. Comes in, and you've got the database, and you go all the way from browser down to database. Fantastic. And this is where, like all of these things, they're all basically commodity, and you can give them all numbers, and they're cattle, right? Not using that analogy. But here, not so much, right? There really is nothing else left, right? Like you can't, like all of these are proxies. They pass things back. You get to the database, and like that's it. There's nothing else, right? So when you're dealing with databases, and you're trying to automate some of this stuff, and you're trying to coordinate a lot of this stuff on the automation infrastructure side of things, you've got to treat this with a slight amount of care, right? So database systems, right, additionally, database systems, they're layered things, right? Like in all of your organizations, I don't know what database you guys use, or plurality of databases, MySQL, Postgres, whatever. They all come with supplemental services, right? A database is not just a single running process on a server, right? It's a constellation of different processes. So, right? So they don't operate in this vacuum. And when you are trying to get some of these components squared away in terms of the additional layers that go into the database, you have to deal with everything from query plans all the way down to replication. Now we're talking about coordination between multiple boxes, multiple processes, right? Here we're talking about the shared buffers, which may be specific to a particular instance, and this gets to be problematic, right? So if you have complete control over this environment, there's benefit, right? Some of those benefits are performance. This is great. We just pulled this off of a couple of boxes this morning. It's nice, right? 9.7 gigabits between two boxes. Rock on. So other things that are also nice when you control the entire environment. This here, this is on the VFS layer for writes. We measure this stuff in nanoseconds, right? So that's like 2 microseconds for all of our write I/O. This is nice. And here, right, operations on the performance on the write side of things, right? This particular workload, we had something going on, and this is 210,000 write operations per second, right, on a 1 second interval. This is great, right? But it doesn't. It comes at a certain cost, right? And there's a certain amount of preparedness that goes into all this too, right? This is the scariest message you will ever see. If you use ZFS or you don't, you might be losing data. But if you are using ZFS and you see this, you count the lucky stars, right? Bit rot happens. So you've got this infrastructure. You do all this monitoring. You go and perform all of this cataloging of the infrastructure, what it is that you're doing in terms of databases and disks, and you've got this complex animal, right? And now I've only been talking about just a single system, right? There's a lot to an actual operating system, right? This comes from Brendan Gregg's performance observability tool. And like, you have this huge stack of things, right, as an operator, database administrator, that you have to take into consideration, right, just for one box, okay? Now you've got lots of these boxes. You have lots of different ways in which external things can impact the performance of this system, right? You've got disk stuff, you've got network stuff. You have, as a result of network stuff, you have coordination with other things. You have contention inside of the actual box itself somewhere, right? Maybe it's in user space, maybe it's in the kernel. You don't really know. And if you go back, right, this is some benchmarking that we just did recently where it turns out that if you look just on a single box, you see the TPS versus the response time, from generation to generation between these two, we end up getting better performance, but then slower things. So like, okay, great. So these are real, like, comfortable things that we're typically used to in the operations world, where you have to measure this stuff, but then you get to this kind of, slightly more broad context of things, and I just lost my train of thought. You get to this more broad context of things, and all of a sudden, like, the complexity of what's inside of a box needs to be applied to the entire system writ large, right? So if you've got hundreds or thousands of databases or boxes that are all interacting, this scale of complexity on a single node there's a lot that goes into this that also needs to happen elsewhere. So risk management, right? So let's talk about this real quick, because this is an interesting aside that is applicable to technologies like Consul, which I'm getting to. So if you've got synchronous commit off, right, how risky is this, right? Is it risky, right? On a block file system, yeah, it probably is, right? On ZFS, I'm not going to get into necessarily the details, but it's fantastic. It's very similar to LMDB in the sense that it uses a Merkle tree so that whatever you write, you will only see whatever the fully committed transaction is. As a result, you have no file system checks, right? But this is all checksummed as well, which is really nice in an SSD bit rot world. So it turns out that, yeah, it's OK if you're willing to accept a certain amount of data loss. OK, fine. Right? So if you've got this loss aversion aspect to infrastructure, right, complexity breeds this desire to not have downtime. And as DBAs and operators, you are in a world where you think, I need to hold on to every single last bit. I need to make sure that as data center power outages go, that 5 seconds worth of data potentially is going to have very little cost because I captured every single bit as it went down to disk in a safe way, right? But as a performance engineer, you're like, yeah, I really just want some back pressure relief, because it turns out that applications, if I have a slow database because I'm F-syncing all the time, it turns out that that's going to cause way more of an outage or have much more impact further up the stack. So like, pop the relief valve. I really want to think, just let this thing scream, right? So what's the trade-off, right? So inside of a system, again, single system, right? F-syncing every transaction, it's basically reckless, right? There's a certain amount of exposure, and there's a trade-off. And if you're doing low volumes of transactions, fine, F-sync, doesn't matter, right? But at some point, I only want you to F-sync periodically because I really need the performance and the velocity, because the cost of those 5 seconds, if I'm really worried about a data center outage, and that 5-second window is like on a whole other order of magnitude, right? 5 seconds is a reasonably small amount of money for all intents and purposes compared to, let's say, having a data center outage. So am I guarding against that 5 seconds worth of outage, causing things to slow down, and then back pressure to causing the rest of the site to spill over? Nah, probably not. So we need to be able to think about this and then begin to quantify it, right? What's the risk? Okay, so if this is what a transaction group, so I skipped past it kind of quick here, oops. But if I've got a 5-second transaction window here, then using these hypothetical numbers, these are not real numbers, and assuming that your revenue is linear, all of a sudden, like, you go, oh, wow, that's a lot of money per transaction group, right? And it starts to add up, especially when you're a large business. So, OK, great. So you've got transactions. Maybe you split it across multiple machines, and your cost goes down. You're building something. You start with, let's say, a Postgres box, and you want to go and spin up a slave because no single database should ever exist by itself, right? So you go and get replication set up. Then you go and like put some kind of HA on top of it. OK, great. You have point-in-time recovery, so I've got some target somewhere that I'm going to go and ship my Postgres wall logs off to, or bin logs, MySQL, whatever. And then I want to have some kind of connection management, so I've got like a fourth-ish thing that I have in this stack, right? Then I want to go and take some of this data, I want to go and ship it off to another data center so that if I have loss aversion, a data center outage, right, I'm covered from this. And then, turns out that actually I really want to go and make my connection management be separate from the physical boxes that are doing my database handling, because connection management is, with PG Bouncer in this particular configuration, I can go and fail over between a master and slave, and I can do this hitless now in PG Bouncer 1.6, right? So this is really nice from an uptime perspective, because now I don't have to have clients reestablish their connections, which is really good because not all developers have retry code and reconnect code in their database, right? Like, how many times have you got somebody in an organization or your organization said, I'm going to go and restart the database. I need to have somebody from the app team standing by so that they can reboot their app, right? You don't want that, but it happens. So in order to get this environment spun up and set up, right, there's no fewer than 5 components here, right? And that's pretty conservative, right? You've got the operating systems for each of these as well, right? And there's lots of different combinations of this, right? When you look through your checklist for doing the provisioning of a large system, not just a small one anymore, because we're outside of the single box at this point in time, you have, right, some form of indirection to talk to the right host. Call them VIPs. DNS VIPs is the DNS service discovery for console. But you have all of these independent layers, right? And that's great. But then remember, we're back in this microservices world, right? So everybody gets their own database, or maybe 5 of them, right? We've massively fragmented our data world, and in the monolith world, it used to be monolith application, monolith database, and we kind of got a little bit smart about that, and we went monolith application, and then federated databases because we all went to sharding, right, as an industry. And now we've done something different where we've gone, federated applications, and we've gone through federated databases. And so we have all of this data split everywhere, and as a result, we now have an inordinate number of combinations and different things that we have to go and push into production. Now, each one of these different things that we push into production have different operational requirements, right? In the case of Postgres, I'm going to keep coming back. It's something that I'm very familiar with, so I'm going to keep picking on it a little. In the case of Postgres, if you want to go and reset some parameters, you can't. Or if you want to change some parameters, you can't without restarting the process, right? A lot of our hosts are in the hundreds of gigabytes of RAM, right? This is now a very common thing, right? You've got 256 gigs of shared buffers and 128 in file system cache and some left over for the OS, and oh my God, restarting the databases becomes a really big, invasive, very, the impact from this restart is large and felt, right? So you can't just willy-nilly go and say, hey, I'm going to go stuff a value into my config management, push it out, and then expect that the entire infrastructure is going to behave correctly. It probably won't, or if it does, and you do push things out, you're going to feel it. It may behave as you expected, but it behaved as expected after a restart, and that's impact, right? So, examples of some of the things, right? You've got the, or other variables, that dimensions to this provisioning, right? You've got compliance, which is one, just as an international company, makes things much more interesting, I guess I'll call them, because you have all these different environments and different parameters that some of them are not technical parameters, they're external and somewhat arbitrary. So, when you get into this loss aversion thing, it turns out that on the architecture side of things, when you're building all this, and you can go through the provisioning aspects and the maintenance side of things, and you can figure out the decommissioning, but then you have to deal with the human equation, because at ODark 30, when you have hundreds or thousands of boxes, an operator needs to be involved to go and unwedge something, right? So you have this incident response, process that's somehow been organized inside of your defined inside of your organization, so that that once you have an incident, you're going to respond. That's people doing that, right? And it turns out if you study large-scale failure, it's not that people necessarily intend to do wrong things, or that systems and processes involved in this technically fail. It's the confluence of multiple things failing at the same time. So we have a way of using console internally in order to build out a stable environment. So let me describe what's here quickly on the screen, and I will explain into the components. This is where things begin to become grounded. So in the console universe, console, and so I'm not going to talk about necessarily what console does, but it's all distributed KV store. We all understand that. Console also does service discovery, does checks, and a bunch of other things. So inside of console, if we want to leverage this, because this is a part, there's just not a lot that does what it does, right? Or there's not a lot that does what console does. And so if you want to leverage what console does do and leverage what console does well, you're going to have to put some, layering around that. And that's largely due to the fact that in the case of databases, you don't want to send them off for slaughter accidentally, right? The worst thing you could do is accidentally tag, your pet with a number and send it off to the avatar. So, so the way that we've built things out and are building things out is by having a business logic layer that goes and takes requests from people, says, I need to go change this parameter, I need to go in and provision something, and it goes and maps this into a normalized model, right? And we store that in a normal relational database, And we actually map all of these things out into observer, using an observer into console, so that console has this highly denormalized form of where we splat out all these parameters in order to support the complexity here. And as a result, we can come back and use console template passively, right? Cron or using watches when that gets fixed. This is one I'm interested in. We're doing some scalability testing on that here very soon. But then to go and run, in this case, we use Ansible to run Ansible locally. Right? We don't use it for its orchestration capabilities. We use it to be able to run plays locally. And we have this running for a number of things right now. And we can go from interface through, in this case, Postgres using its listen interface, through an observer, through console, and then actually go and effect change. And we can do that in less than half a second if we want, using an actual console watch back here. And this works really well because when it turns out that there's a couple reasons this works well. So first off, on the DNS side of things, here we have, on the database side of things, we have long-lived connections. Right? So clients don't pound the database, or they don't pound the DNS server continually because their connections are reasonably they're reasonably long-lived. The way that we provision this internally is we go and use and manage everything through run it. So as a process manager, we go and spin things up, and it's a very like running console is reasonably simple in the sense that the environment variables that we care about, we set the path, we set the go max procs, and then we specify a series of config files per instance, right? So if I've got a sea of databases, they're all running around with these little JSON files. We manage those externally using Ansible. We render those out as a result of the input in the contents of these console files, or console KV entries here that originally came back through the database. So the actual service definitions themselves, right? In the service definitions, we go and provision in a default deny config. We go and provide some kind of a service, right? Specify a tag that says that so that we can go and queries whatever, some database timeline using read-only. And we give the actual, the database team a token so that they can go and provision and register using when I was scrubbing this, I scrubbed the prefix, but we use a prefix ACL in order to grab in order to prevent the other arbitrary teams from hijacking the service namespace. So I almost want to go fix that. And we run this on a reasonably frequent basis so that we can spin up and spin down database slaves in a reasonably unimpactful way. So getting into this, in order to make use of console here, right, we have to go and figure out how to meet the business requirements specified here in these parameters using some kind of a business mapping layer, right? And so we have that in the form of an executor here, which goes and pulls information in and out of the database, goes and figures out what the entire state of the system is, reasons about it effectively, and then goes and writes something back to itself, and a job goes and picks that up, this observer process, goes and picks that up, and then goes and pushes that out into console. This gives us the ability to have components fail, right? So one of the things that I've skipped over here is in the execution of Ansible, it runs locally. We deliberately built this buffer so that if this line here gets cut, where console template is somehow disconnected from console, it doesn't impact us. It's really important. If the template gets rendered, we can put a block here, and we can just run this by hand. We have the abilities for administrators to go and use the exact same tools that our automation framework does, right? This means that when something happens, we can go in and triage the incident after the fact, and back that change back into the config management system. And we can go and figure out where exactly we had some potentially bug up here further up in the stack, right? but it gives us the ability from an operations perspective to go in and triage the system here, do something potentially by hand where a human interacts on whatever the object is, generate the playbook or back into the playbook that we actually need, go and figure out how we missed it somehow in the API layer, and go and prevent this from happening again. But we can do that after the fact, right? We're not in the position of being down and saying, hey, hold on, I need to go and automate this, right? We don't want that. We want to be able to go and firefight, go and figure out what's going on, and then deal with the cost efficiency of things at a later date. So, as an example, right, we have, going back to the regulatory comment, we have Postgres, and we limit access to the, let's say, this foo database. We're going to limit it so that the database account can only come in from these 2 IP addresses, and the application account can only come from this one. Well, this is great, and also pain. It's really problematic to go and tell developers, hey, you can now deploy into production, but you don't have access because we haven't enabled it. So that doesn't work in a dynamic world, microservices world. So you have to go and have these triggers and mechanisms to go and update these entries, these HBA entries, on a reasonably frequent basis. HBA entries, and by themselves, we don't use for compliance. We have to use firewall. So that means that now I've got a firewall rule that I need to have synchronized with a PGHBA rule, right? I only want to have one source of truth for all of this information, right? And I can do that now because I have this distributed state engine that I can use for cluster management. I can say, what are a list of all the valid IP addresses that are supposed to be able to talk to this one particular instance? I can do that. I can render that out, and this is fantastic because I can do that at machine time. Consul gives organizations the ability to go and have systems be reactive at machine time. The way that this used to happen, if you wanted to use DNS-based load balancing to go and figure this stuff out, is if you, let's say, had DNS entry up here, you'd have to go and push a DNS entry or have something that handled the registration of dynamic DNS entries by hand based off of an alert or an alarm or somebody pulling the trigger by hand. Consul, when you run this every 10 seconds, is doing this at machine scale, at machine timeframes. Right? There's nothing that you have to do as an administrator in order to handle a lot of this. I want to be notified, by the way, whenever this check fails. I very, very much want to know, because for some reason it failed. Something that should have been steady state stopped being steady state. And I go back to the system diagram above and dig into the problem and go figure that out. But Consul now gives us that ability right here. Right? The ability to have clients through the DNS interface end up talking to the right host or set of hosts that are deemed to be healthy is of huge value. So when provisioning, finds in order to leverage Consul, you want automation. You don't want to be in a situation where you've automated something and then you can't safely use that automation because it somehow doesn't work or doesn't map well to Consul. For our case and our purposes, we've tested and found Ansible to be very effective for this. One of the important lessons that we have figured out is idempotent execution makes a great deal of difference for simplifying the way that you think and reason about things. So I don't care necessarily that what the performance of the provisioning aspect of things is. I mean, I don't want it to take weeks or days even, right? But I don't care that it takes like 15 seconds or 30 seconds. That's reactive on that scale. That's configuration. So when you have an incident, I want to be able to dynamically react, but that's not compiling out and building your infrastructure. So on the provisioning side of things, in the case of databases, I mentioned the shared buffers earlier. If you have shared buffers and that requires a restart in order for you to change, you go and spin up a new slave and you fail over to it because now that's a controlled crash and within your control. Right? What you don't want to do is make a change and then have that change potentially go out and spread out. You want to go provision a new slave with a particular set of parameters and then move on with life. You don't want to go in and change a parameter, have it pushed out, and then all of a sudden reap the consequences. So, or the other one is you can do it old school. Go get a DBA. Go find somebody to go and handle this restart by hand. So one of the things that's been interesting in the rollout and deployment of this is we run into this cost benefit of automation where, efficiency versus efficacy, right? If it takes you 12 man-months or 3 man-months, and you're only going to do this particular task once every 5 minutes, every 12 months or whatever, there's no cost justification ever for going and automating this thing unless you're going to do it continually. So as you're making organizations are making transitions into, I should have put another copy of this slide, making a transition into some type of an infrastructure that buttresses and wraps console, there's a certain cost to that. And you don't need to go gung-ho into this in order to leverage the benefit. In order to leverage the benefit of console, there's a certain amount of reasonableness to all of this. And it means looking at what it is that you guys are doing and saying like, okay, I don't need to automate this, and I do need to automate this. This is really important to my organization. So, and I bombed through that a lot faster than I actually thought I was going to. Questions?
Questions? If you have any questions, please line up at the microphone over here, and we'll go till 1 o'clock, so 18 minutes.
Hey, great talk, by the way. So you are using console and console's DNS for service discovery on your DBs.
Yeah.
Are you using that without any caching on the DNS queries at this moment?
Right now it's set for 5 seconds, and we allow for stale reads. In the
Okay.
event of a partition, we would rather make forward progress knowing that we're potentially talking to the wrong thing.
Sure.
At the end of the day, the databases are still serializing the information going to disk, and we trust them. So if you have a slave database, we expect it to be in a read-only state.
Yep, sounds good. No other, I'm going to ask more if there's.
Yeah, go ahead.
Others. So the other, you're talking about the watches and talking about performance around watch. I know that on the console mailing list there was some issues around performance in watches. Is that basically where you're concerned right now?
Yeah. And I missed the name of the person giving the talk before at Stripe, but running it in cron is something that we've definitely looked at, and in small scale it's fine, but in larger scale we're definitely interested in, and probably going to end up running it that way.
And then can I just ask how many service definitions you have in console at the moment?
It's
know?
growing. No, it's growing.
Yeah.
I do know that. Sorry. Order of magnitudes, we're definitely into the hundreds of thousands.
Yeah. So that's hundreds of thousands, but not coming from single hosts or?
Correct.
Yeah.
Yes. So one of the things that we do like about, let me go back to this though. One of the things that I do really like about console is, there we go, is the fact that this information comes from the edge.
Yeah, totally.
Right? And we very much rely on the fact, from a human auditability perspective, that these files are external at the edge and don't exist in the core. Yeah, you can push it, do an API call into console in order to register something, but this means that I can have somebody go back and a local administrator who's not versed in console figure out what's going on. And this is very easy to reason about, right? That human factor that I glossed over, it can't be overstated enough that it's typically a result of, or like outage is typically a result of not console failing or Postgres failing or MySQL or any of that stuff typically failing in isolation. It's typically a confluence of operator error and the machines, and there's some extraordinary event that's happening in the form of, something.
Sure. And then add one more. Oh,
Go ahead.
On the back pressure versus losing your 5 seconds question. So I guess that only really makes sense. I guess you did the math already, but it only makes sense if that 5 seconds, if the cost works out right? Like, I mean, that's kind of weird. I've never really heard a DBA come up and tell me, we can lose 5 seconds of transactions. That doesn't sound like
that's exactly it, right? Like, and that's the point, though, right? Is like we all have this inherent loss aversion, right?
Yeah.
And so we have this really, really like highly refined sense of loss aversion that's just ingrained, right? every single time you commit a transaction, it must go to disk instantly.
Well, I mean, at some point, isn't that just like why are you using the SQL database then, right? Like use something that's eventually consistent or something else if you don't really care about that.
Correct.
Is that maybe the wrong choice at that point, or? I mean, it's a rhetorical question. It just it seems.
We can maybe talk about some of that
Sure.
stuff over beer.
Yeah.
But if you don't have to worry about the consistency, it's okay at some point to put as like when you're making some kind of a decision, in order to support your decision, you can look at the actual cost, right? It's not just entirely about correctness of one small aspect of the system. The correctness is the entire system as a whole, which includes all the applications running in the entire data center, is it up and available,
Sure.
right?
Yeah, then we don't care.
Yeah.
Yeah. I'll let you go, sorry.
And so it's really like they're fsync, but only when, right, the velocity of transactions exceeds, right? Don't be reckless. But that definition of what's reckless and what's not changes based off of the operating environment. Okay. Right. Right.
Well, what happens when they replay?
Well, so here's the thing. That's exactly right. It's a really complex question, and there's many things to unpack out of that statement, right? But if the thing that we're guarding against is a pull the plug power test, right? If we lose power to our data center, we have much larger problems than the last 5 seconds worth of data, and we're willing to make that trade-off, right? Or sometimes willing to make that trade-off. And this is meant to be provocative to get people to think, but it's at the same time in the context of this system, like thinking about systems as an individual host, there's a lot of loss aversion that we put there, but that same kind of loss aversion also needs to be applied to some of these other mechanisms and other tools when you're dealing with larger scale systems, and it's a slightly different type of loss aversion as a result of humans, not fsync or powers.
Cool.
Go ahead.
Hey, I'm Mark. Sean, great talk. I wanted to take a step back because I wanted to get the full context of how you designed all this.
Mm-hmm.
Was the goal ultimately to create not a configuration management system, but a change management system to enable databases as a service?
It was, so there's a number of things that kind of drivers that went into this.
Yeah.
One of them was the evolution of data center networks away from flat L2 networks to how do you span multiple racks, multiple geographic areas, regions. How do you do this without relying exclusively on load balancers, which are have nice self-healing properties because they'll pull something out of rotation, right?
Or
so that was
abstracted away from via network and VLANs.
Yeah, that's exactly it, right? So how do you do that? But then how do you do something, or how do you build something that responds at machine scale in kind of complex ways, right? How do you deal with these how do you deal with the concept of a network partition without some form of distributed state machine that is partition tolerant, right? Now, in order to go and support something that is partition tolerant, how do you build a system so that you don't blow your foot off, right? Because databases have real important information in them. If you accidentally, shepherd off a database into the wrong, cattle line, everybody's going to have a bad day, right? So how do you put the safeguards in place?
So you enumerated other components of the system outside of console to build this entire system, leveraging console and Ansible and other things to actually, implement the final states. Is that an open source project you ever conceive of today?
Actually, I'm kind of glad you asked. It's not yet, but I am on the approval track to get it there.
Excellent.
So yes, I was hoping it would be done by now, but obviously it's not. So I'm a little hand wavy, but yes, it's on its way to being open sourced.
Because you described basically the inputs or the manipulated states, factors and variables being business values in a sense, right?
Yep.
And that was very curious to me. I mean, it's absolutely true, and it is ultimately what we all need to relate to, right? Is how we improve the business.
Yep.
So I wondered, how can you describe that process? Because again, this would be a seed to how you designed the entire system, I imagine. Well, the quintessential seed.
So one of the more difficult aspects of things in this is all straightforward here to describe in some kind of a configuration system. What's not is some of the individual things that go into this aspect, right? Where we have to go in and take that and add the regulatory things. So the code in here, making that less Groupon specific is of
course
a feature.
It's a 0.1, I understand.
Right.
Okay, thanks so much.
Yep. Other questions?
We still have about 8 minutes if anyone wants a question.
Yeah, I moved through that, sorry.
No.
I can just talk to you.
Yeah, actually, so this is Jerry, one of my coworkers, who actually helped build and design a huge chunk of this. Yes, so one of the important things, actually, thank you. So if we have denormalized state information that we store in console, the executor actually passes back and queries Aaron. So one of the things that we have an issue with is the liveliness or staleness of information. Aaron represents an API interface to the source of truth. I don't care what it is, right? Aaron acts as that broker that's going to go and be able to figure something out. So if the executor goes and talks to Aaron, minutes later, potentially, microseconds later, it doesn't matter. Aaron, it has the source of truth, but it doesn't actually hold the source of truth. It just knows how to go and proxy things so that as an organization, we can go and figure out how to query across large sets of things and gather the results back, make some kind of intelligent decision about that, and then push the result over to console, right? Aaron doesn't hold information. All of these random systems down here do, right? Like power systems, and there's truth there. Aaron doesn't have it. There's no master vision of everything because in an asynchronous world, not everything has a chance to phone home and be authoritative in a particular moment in time. So, in the case of, let's say, Postgres, when you're deploying large numbers of things, you can be prescriptive and you can say you can have any color you want as long as it's black. When you start to escape out of that single service database type mindset, that suddenly breaks down because people really do have both needs for trucks and other types and colors cars. There's just a lot more complexity that goes with that. And so Aaron was intended to be able to kind of like wrap its hands around that level of complexity that you just can't stuff into a single schema. Yeah, that's cool.
So this might be a dumb question because it might be one of those cases where just running the system populates all the data. But like, did you work out like a DR strategy for your console store, or like, is it just spin things up and they repopulate and we're done?
So, yes. So we have not figured out the DR component completely because we knew that prepared queries were coming in console 0.6. And so we're like, we're going to table that conversation for just a little bit, and then we're going to go deal with it.
Sure,
because we know that this functionality is largely going to enable this. The tomography stuff I am super, super excited about because in the event of a network split, like life will continue to move on to the nearest slave. And yeah, like there's a whole bunch of things that are going to come there that I'm very excited about. But we're seeing this evolution and incremental progress towards this kind of like, self-healing type universe for important components that, have persistence and state, like databases.
Can I ask another question?
Of course.
Yeah. I know you don't have slides for them, but are you guys using console somewhere else in your infrastructure that you could like maybe briefly kind of run down the use case?
The next one actually that's going to be happening shortly is these guys, point in time. So having these designate so that a particular timeline, so if you've got a master slave or series of slaves, we call this a timeline of database information, and we take the point in time recovery information from a particular timeline and we want to go and ship it off to a consistent place. So we're using console to go figure out what SSH server to go and zip that information off to. And that's potentially going to change as we bring up and turn down different bricks. So very simple in that regard. We're just using it as a DNS interface for SSH endpoints, right? But it's potentially dynamic as well.
That's awesome.
Or
Thanks.
definitely going to be dynamic.